Hey, today I will show you how to solve one of the top 100 questions in Leetcode called valid palindrome, which falls into category of strings. This question has been mostly asked by Facebook, but according to Leetcode, it also asked by various other companies like Adobe, Apple, Google, and some other companies like so. Our primary language of choice is going to be JavaScript, and we will explore two separate solutions for solving this problem. One of them with O of n space complexity and the optimized one with constant space complexity. So without further ado, let's dive in. Okay, let's go through the problem first. A phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string of S, return true if it is a palindrome or false otherwise. So let's see some examples to further understand this problem. In the first example here, we have a string like that and output is true. It's a long string, but if you check the characters, it's palindrome. One thing that we need to take in mind from this example is that we might exclude any special character and spaces. Moving on to the second example, our output should be false for this. Again, we might ignore all the spaces in this case, and as you can see, we would end up with something like this. But the reason that output is false for this is these two characters don't match up together. And our last example seems like we've got an empty space, and since we might not consider any spaces again, we will end up with an empty string. And according to explanation of, since an empty string reads the same forward and backward, we might conclude that this is a palindrome. So we might return true for that as well. So how we can solve this issue? If we take our first example, and as we understood from examples, we might need to remove any special characters first, then spaces, we will end up with something like this. But in order to more unify this, we will do one more hidden step that we saw in examples. We will lowercase them all. This is going to be our final string that we are going to check, but how will be the check process itself? If we take outcome of our previous slide and define palindrome one more time to ourselves, it basically means checking values one by one from each end of our string to see if they match. In this case, it means putting 2 pointers in each end of our string like so. Now, if we continue here in our check, we will end up in one of two situations here. Either both of pointers collapse at one single point like this C character here, or they just pass each other, which is going to be the breaking point for our loop. But if we think about our second example, just note that at any point in this loop, if one of two characters don't match up together, like E and A in here, we will break from our loop and immediately return false. Bottom line is, if we continue to match pairs and we finish our iteration without any breaking out, then we finally going to return true from our simple algorithm. So let's get into the code now. Here we are in Leetcode. First thing we need to do is converting our string to lowercase and removing any extra characters of it by using a regex map. Something like s equal to s dot to lowercase, and then replace a regex string like anything except 0 to 9 and A to Z. Replace it with nothing basically. Then we will define our right and left pointers like let left is going to be 0, let right is going to be s.length -1. Next we will do our loop with the left and right pointers like while as long as left is less than right, we want to do iteration. Inside of our loop, we will check if characters at those indices match up together. Something like if s at left index is not equal to s at right index. If they don't match up together, we are going to immediately return from this loop, like return false. If it is not the case, we are just going to increment left pointer and decrement right pointer in order to check for other locations, like left plus plus and right minus minus. At the end of our algorithm, we now pass through our iteration and we haven't found any two characters that don't match up together. So at this point, this is definitely palindrome string. So we are going to return true here. Now let's run our smoke test to see if everything works fine. And as you can see, it works fine. And if we submit, Leetcode will accept our solution. Now let's check for time and space complexity for this algorithm. For time complexity, we are just having a for loop over our string. So we will have O of n time complexity, where n is the length of our string. For space complexity, we are creating a new string with the solutions. So again, it will be O of n, where n is the length of our string. But usually, here's the point that your interviewer asks you to optimize your algorithm with constant space. They usually bring this up as a follow-up question to see if you can come up with a constant space solution. In order to optimize our space, we need to provide a solution without recreating a string, because imagine we could have an input string with millions of characters. So that means two things basically. First, we need to find out another way of checking characters. I mean something without rejects and to lowercase especially, because that was the cause that we were ended up creating a string all the time. Second, we need to figure out a workaround for special characters like comma, semicolon, and things like that. For that, we are going to use ASCII Chart. ASCII Chart is the most common character encoding format for the text data in computers and basically on internet, which contains everything you see in this table, and they are assigned to a special number. I know that this table seems to be a bit scary, but you may ask how this is going to relate to our solution. We are going to need only some part of this table, but before that, I need to explain something shortly. Basically, here are some documents from MDN about character code at method on a string. Link in the description for this, but what I want to point you at is this line here. The first 128 Unicode points are a direct match of the ASCII character encoding. So in an example like this, the char code at method on index of 0, which is a letter A of string ABC, will return the same ASCII code that we saw earlier in table. So back to the table, we basically want to know three things for our algorithm. First is going to be uppercase letter code range. Second is going to be lowercase letter code range. And finally, numbers. I know for a fact that some test cases in Leetcode includes numbers in them. As you can see in the table, the range between 67 to 90 are for uppercase letters. Between 97 to 122 is for lowercase letters, and the range between 48 to 57 is for numbers. Since these character codes are a global standard, in order to convert uppercase to lowercase, we need to move exactly 32 rows down to get from an uppercase letter to a corresponding lowercase letter. For example, let's take letter C here. Its char code is 67. Now, if we go 32 rows down, we will end up in number 99, which is the char code for lowercase c. And that is going to be our simple function in order to calculate character code for lowercase letters. With that, let's implement the constant space complexity solution. Here we are again in Leetcode to write our solution. First, we will define our left and right pointers, like left is going to be 0, right is going to be s.length -1. Then again, our iteration, while left pointer is less than right pointer. As long as that's true, we want to do some iteration. Next up, we will get ASCII character codes for letters of those two pointers. Something like left char code is going to be s.char code at of left pointer. Exactly the same for right pointer. Now it's time for detecting if those characters are actual letter that we are looking for, because if they are not, we want to skip them by continuing forward in our loop. For that, we will create and use a helper function called isLetter, but we will get back to that later. For now, isLetter is kind of a black box that will only tell us if the given character code is letter or not. Simple as that. So we will do something like if isLetter left char code. But if it is not, we are going to increment our left pointer and continue in our loop. We are going to do exactly the same for right character by decrementing it. Now you see that how we are going to skip values that we are not interested in, like semicolon or characters or something like that. Next, We are going to do two things. First, we need to lowercase our characters, again by defining another helper function with a simple formula that I explained before, the plus 32 rows things that we need to look for. Then compare lowercase character codes in both pointers to see if they match up together. So if we get the lowercase character code of letter in left pointer and compare it with right pointer, something like if to lower left car code, and compare it with right pointer to lower of right car code. If they are not matching together, we are going to return false. Otherwise, just increment left and decrement right pointers again to check other locations in our string, like left plus plus and right minus minus. Again, finally, we will return an explicit true, return true, because we finished our iteration already and did not find any falsy case, so this string should be palindrome at this step. Now, before testing, let's write our helper functions. For isLetter function, we will simply check for the same three ranges on ASCII chart. So something like function is letter, it will receive a character code and it will check for three things. First is going to be number, and then uppercase, and then lowercase. So for numbers, we are going to check the ranges between 48 and 57. So if code is larger than equal to 48 and code is less than equal to 57, we know that this is for numbers. Another check is for uppercase letters. It's the range between 65 and 90. So if the code is larger than equal to 65 and if the code is less than equal to 90, we know that it's going to be in range of uppercase. And finally, the last check is going to be for lowercase letters. It's between 97 to 120. So if the code is larger than equal to 97 and code is less than equal to 122, then we are sure that we are in range of lower case letter. So if that's the case, we are going to return true. Otherwise, we are going to return false. For to lower function, again, simply we will look for 32 rows below of a given character code to return lowercase. But we know that the uppercase values are bounded between 65 and 90 ASCII character code range. So we need to check it first to be in the safe side. We will do something like function to lower. It will again receive a code, like character code. And we will do a check if code is larger than equal to 65 and code is less than equal to 90, then we need to return code plus 32 rows in order to get the lowercase, else we are going to return the code itself. Now it's the moment of truth. Let's run our smoke test. As you can see, everything is passes, and if we submit this, there we go. We are like 99%. That's kind of a nice number there. By doing that change in our code, our time complexity is still O of n, but this time we just optimized our space complexity to be constant instead of O of n. With that, I can say thank you for watching, and if you liked the video, please like, subscribe and write comment below. Finally, hope you enjoyed this video and see you in the next one.